Hi, welcome to CGDive. In this video, we'll be talking about improving the quality of your meshes. I won't be showing you how to model anything step by step. I kind of assume that you can do basic modeling, but maybe you're frustrated by problems that seem to mess up your meshes and you just can't put your finger on the exact issue. If you often experience such strange and inexplicable glitches when 3D modeling, you may find this video interesting. So this video is not about modeling tools and topology and so on. These topics are important, but I want to talk about something more basic than that. Since I started CGDive, a lot of people have sent me their models when they experience problems, especially rigging problems, but also other types of problems. And consistently, I see the same few issues over and over. These problems are not difficult, but they can be hard to detect because often they're not visible in the 3D viewport. Some of these are scale, rotation, and location issues, inverted or inconsistent normals, disconnected mesh chunks, bad symmetry, symmetry may not be as simple as it seems, and so on. By the way, if you're really new to 3D modeling and need step-by-step tutorials, I'm going to recommend a couple of really good resources at the end of the video, so stay tuned for that. If you want to support the channel, consider becoming a patron on Patreon, or you can now join the YouTube memberships. You can also get 20% off all of my Gumroad products if you enter coupon code CGDive at checkout. To understand some of the following problems and solution better, we have to make sure that we understand the difference between objects and meshes. I'm going to create good old Suzanne here, and a mesh is, if I go into edit mode, all of these vertices and polygons and edges that I see here, that is the mesh. The object, on the other hand, is defined by certain features. The object has a name. You can see it over here in the outliner. You can also see the object name under object properties. In this case, the object is called Suzanne, and if I expand the data here, we can see that it contains the mesh that we just saw in edit mode. By default, objects and meshes will often be named the same, so you may think that this is one and the same thing, but really it is not. I can name these things differently. If I just double click on the object, I can rename it, and then I can rename the mesh to something else. The mesh properties are found under object data properties over here, and here again you can see the name of the mesh. I could create a cube here and move it to the side, and then under object data properties I could change the mesh that it contains to Suzanne. And now I have an object called cube, which however contains the Suzanne mesh. And since these objects contain the same mesh, they are called linked meshes or linked objects. If I edit one of them, the other one will be edited simultaneously. By the way, if I go to object mode and press Alt D rather than Shift D, I can make a linked duplicate of this object or of this mesh. Now this new object is called cube001, but it contains the exact same mesh. The idea of linked meshes is not very important to this video, but I wanted to mention it. I think even intermediate Blender users do not really understand this concept. I'm going to undo. And now another important feature of an object is the pivot point, which is this little dot. It's usually somewhere inside the actual object. You'll see that the cube has its own pivot point and Suzanne has her own pivot point. And that is the point around which this object is going to rotate and also scale if I press R or S. Also, if I animate this object really quickly, and calculate its motion path, you'll see that what is really being moved is the pivot point, and the mesh kind of comes along for the ride. And finally, an object has an imaginary bounding box which encapsulates the exact dimensions of the mesh. To make this less imaginary, you can actually go to Object Properties, Viewport Display, and Enable Bounds. And that will show you this bounding box. And this bounding box is defined by the outer edges of the mesh. If I go to Edit Mode and edit one of the outermost vertices of this mesh, you'll see that the bounding box is being updated automatically. So let's start with the first of the common problems, scale. All objects have a scale parameter. You can find it under nPanel Tools, Scale, and also under Object Properties, Transform. Again, you'll find Scale. Do not confuse scale with the dimensions values that you see at the bottom of the nPanel. Dimensions simply show the actual world size of this object, and you don't have to worry about it. It's just for you to know how big your object is. Scale, on the other hand, can create all sorts of problems. By default, when you create a new object, scale will always be set to x1, y1, z1. The x, y, z values are a multiplication factor. The default size of any object is the bounding box defined by the actual mesh. And so when x, y, z are set to 1, that means that the default size is maintained, because anything multiplied by 1 is not changed. If I start playing around with the z value here, you'll see that the monkey gets stretched on the z-axis. And that is the same as using the scale gizmo on the z-axis in object mode. I set the scale values to something different than 111, and that can lead to problems. One very obvious problem is when we apply some modifiers. So let's work with the cube, and I'm going to scale it on the z-axis a little bit. And I'm going to give it a bevel modifier. And you'll see that the bevel on the top plane is much wider than the bevel on the sides. Okay, if I undo, that is similar to beveling this object and then scaling it in object mode on the z-axis. Another example is parenting. I already scaled this cube up a little bit. I'll set Suzanne's scale to 111 again. And now if I parent her to the cube, to the scaled cube, at first everything may seem fine. But now if I select the cube and scale it again after this parenting operation, first of all, Suzanne will get squeezed, but also if I try to rotate her, you'll see that the rotation is behaving very, very weirdly. When we first parented the two objects, Blender used something called matrices to offset the scale of the cube and to make things behave as the user would expect. And I almost wish that it wouldn't do that, because sooner or later things may start to break down. As you saw, when we scaled the cube after the parenting operation, things started to behave weirdly. So this may seem complex, and it is, but that's okay, because my goal is not to show you all problems related to scale and how to fix them, but simply to make you aware that these problems exist. Fixing scale issues once they are present is difficult. It is best to avoid them. And to avoid them, you just need to keep your scale to 1 consistently. You just have to make this a habit. There are 3 things that will help you in this area. Number 1 is clearing the scale. So if I select both objects and go to Object, Clear, and Scale, that will clear the scale of the cube. Suzanne still appears kind of squashed. That is because of the parenting and the matrices that I mentioned. If I just unparent Suzanne, she'll be back to her normal size and a scale of 111. Secondly, you can apply the scale. Applying the scale will also set the scale values to 111, but it will bake the current dimensions of the object into the mesh. So whatever you see in the 3D viewport will become the default size of the mesh. For example, if I stretch Suzanne on the z-axis and then I go to Object, Apply, Scale, you'll see that the Z scale value became 1, but the mesh kept the modified shape. And finally, never scale in object mode. This is my best recommendation. I'm going to undo these changes. Now I have the normal Suzanne. And now if I want to change the size of Suzanne without affecting the scale, I can simply go to Edit Mode, select all vertices and polygons, and press S and scale her up in Edit Mode. Then if I go back to Object Mode, the scale stayed to 111, while the mesh was changed. So these are the main things to note about scale. Next we have rotation, which you can also find in the end panel. And the problems with rotation are similar to those of scale, but in general they're less severe. In many, if not most cases, it is not a problem to rotate an object in object mode. And then you can parent to them, and generally you may never notice a problem. Problems with unapplied scale may surface when you try to actually rig an object with an armature. It is advisable to have the rotation of an object that will be rigged, applied, or cleared. You can clear the rotation from the same menu, Object, Clear Rotation, or you can apply the rotation. So if I rotate this object randomly and go to Object, Apply Rotation, that will again zero out the rotation values. By the way, unlike scale, the applied rotation is 0, 0, 0, not 1, 1, 1. And by applying the rotation values were zeroed out, and this became the default state of this object. Now this was a little bit too random, so maybe if I undo and rotate this object 90 degrees on the z-axis, and then I apply the rotation, now we have Suzanne that is looking to the side in her default pose. We also have location. A location of 0, 0, 0 means that the pivot point, or the origin of this object, is right in the center of the world. Clearing and applying location can feel a little bit different and less intuitive than rotation and scale. Let's move this object away from the center of the world. And now if I clear the location, that will move the pivot point and thus the whole mesh to the center of the world. I'll move Suzanne away from the center again. And now if I apply the location, that will keep the position of the object, but it will move the pivot point back to the center of the world. And location will be zeroed out. So, like rotation, it is not much of a problem to move your object around in the 3D scene. This is generally how you build scenes in the 3D world. But some rules need to be observed when rigging again. And I'm going to talk specifically about rigging a little bit later. Okay, enough about location, rotation, and scale. Let's talk about symmetry now. Many objects and characters are symmetrical, and Blender allows us to model, sculpt, and paint in symmetry, which can be a huge time saver. However, there are a few pitfalls. There are ways in which you can screw up the symmetry without realizing it. First, let's point out some of the ways in which you can work with symmetry in Blender. First, in edit mode, if you go to Tools, you have the XYZ mirror options. Sculpt mode has a dedicated symmetry menu. You can also set up XYZ symmetry. Texturing also has a similar menu, and you can mirror on X, Y, and Z. And weight painting is a bit special. It allows XYZ symmetrical painting, but when it comes to painting symmetrical bone weights, it only allows symmetry on the x-axis through this vertex group X option. This is something I explain in my weight painting videos. Please watch this playlist for more information. And of course, there is the mirror modifier. If I only have half of my mesh and I apply a mirror modifier, I will create a non-destructive symmetry. This modifier also has options for mirroring on X, Y, and Z. So most symmetry tools in Blender can work on any axis, but the weight paint tools for bone weights only work on the x-axis. And for that reason, when working on symmetrical characters that will be rigged, you should have them face forward. Like here, if I press 1 on the numpad to go to front orthographic view, I can see my character's face. He's facing forward. That way I can make him symmetrical on the x-axis, and I can use X symmetry in weight paint mode. That's a limitation of the current system, but in 99% of the cases that's not a problem, and in the future this may be fixed. There will be updates to the weight painting, but I'm not sure what exactly will be affected, so for now we just need to accept this limitation. So a truly symmetrical object will have a mirror image of each vertex on both sides of the mesh. In the case of this character, it is symmetrical on the x-axis. And in object mode, I'm going to apply this modifier. And now if I compare the location value for two symmetrical vertices, let's say this one, under item, I can see its exact location, x, y, and z. And now if I compare this to its counterpart on the other side of the mesh, you'll see that they have the exact same values, except that the x value is positive on one side and negative on the other side. And when that's the case, if I go to Tool and activate X Mirror and move some of the vertices, you'll see that I'm manipulating only the vertex on one side, but the vertex on the other side is being affected automatically. So far, so good. Nothing complicated, I think. But let's see how we can actually break this symmetry. One very simple and obvious way is if I turn mirroring now and I move this vertex, then it will no longer have the same values as the vertex on the other side. And now if I activate mirror again, mirroring will not work anymore. Let's undo. But there is something less obvious than that. If I go to sculpt mode and start sculpting a little bit, and then let's say that I want to smooth this character a little bit. Now if I go to edit mode, X mirror is activated, but if I try to move these vertices, the one on the other side are not affected, even though they seem pretty symmetrical still. And I used symmetry in sculpt mode. I forgot to mention it explicitly, but here it is. Mirroring on the x-axis is turned on in sculpt mode. And so if we compare again the values for these corresponding vertices, you'll notice that there are very tiny differences in these values. They're tiny but big enough to break the symmetry. Now, even though this kind of symmetry in edit mode was broken, I can go back to sculpt mode and press G to grab, for example, and I'm still sculpting this mesh symmetrically. So it's almost like there are two types of symmetry. One, for sculpt mode, for example, is a little bit more fuzzy and forgiving. It just needs the vertices to be close enough and it can work in symmetry. But the one in edit mode needs to be very precise. And the exact same type of precise symmetry also works in weight paint mode. So if you're going to be painting symmetrical bone weights, then you should be very careful not to break your symmetry. So these are some of the problems. Now let's see what we can actually do to keep true symmetry. Probably the best way to work with symmetry is to use the mirror modifier. Again, if I only have half of my mesh, I can add a mirror modifier to it. And this modifier always keeps proper symmetry, true symmetry, no matter what. We basically just have one main half of the mesh, and the other half is constantly being updated whenever I do any changes to the main half. I can move vertices, I can go to sculpt mode and sculpt. I can even smooth. I can do anything I want. And then at any point I can go to object mode and apply the modifier, and that will give me a perfectly symmetrical mesh. I'm going to undo until I have my mirror modifier back. So for symmetrical characters, I recommend modeling using the mirror modifier. Then once you're done modeling, you can apply the modifier and start working on UVs, then on rigging and so on. So I'm just going to give you a few quick tips about using the mirror modifier. One common problem with it is breaking the center line of the symmetrical object. So if I go to edit mode with the default mirror settings, and I should also turn off the mirror under tools. And now I can move these center vertices and basically break this center line that I have. The center line is where the left and the right side of the object connect. And ideally it should be a straight line right through the middle. So to fix this, you can go to object mode, position the 3D cursor at the origin of this object. So if it is not at the origin, I can press Shift S and choose cursor to active. Then I'll go to edit mode, switch the pivot point to 3D cursor, and then I'm going to select all of these vertices from the center line and press S and X and then 0 on the numpad, and that will flatten this line right at the center. And now to prevent ruining this center line in the future, I'm just going to enable clipping under the options of the mirror modifier. And when I do, these center line vertices will always stick to the center. I won't be able to move them away from the center. And another common problem that I see is keeping a polygon at the center line of a mirrored object. So I think that usually happens when people start modeling. So I'll go to object mode and create a new cube. In edit mode, I'm going to move it away from the center. Right, add a new mirror modifier and enable clipping. And now if I move the cube towards the center, I'm going to have a symmetrical object with a proper center line. However, if I enable X-ray here, you'll see that inside the center line there is a polygon. It's even easier to see it if I disable the viewport display of the modifier. Here's the polygon. I'm going to select it and delete it, and then enable the viewport display again. And now we have the mirror modifier properly set up without a polygon in the center. Okay, that was just a quick demonstration. I'm going to delete this. And these are the basics of using the mirror modifier correctly. Now let's move to another solution. I'm going to apply this modifier. And let's go to edit mode and break this symmetry a little bit by moving some vertices, without having any mirroring enabled. So another way to symmetrize a mesh is in edit mode. Now if I select all vertices and go to mesh symmetrize, you'll see that symmetrizes the whole mesh. But you have to be careful with this because this feature is destructive. I'm going to undo and let's switch to the UV editor and I'm going to repeat the same action. Notice how a lot of the UVs seem to have disappeared. This is because the mesh symmetrize function basically deletes half of your mesh right in the middle and then it mirrors the remaining side of your existing mesh on the other side. So even though that's not obvious, that is what is happening under the hood. So if you have already laid out your UVs and stuff, you have to be really careful or you should avoid this feature. But at earlier stages of modeling, it can be very useful. So next, let's undo actually. And let's say that we have this mesh with nicely laid out UVs, but we messed up the symmetry. So another function that we have under mesh is snap to symmetry. This function tries to find vertices where the symmetry was lost and it attempts to fix the symmetry. So in this case, you'll see that it kind of found one of the symmetrical vertices. The other ones were probably too far away from their original position, so the function couldn't find them. But there's this threshold value. If I increase it, I may be able to find them. And so increasing this threshold value may help you fix problems, but it can also introduce errors. So you have to be careful with it. But you'll see that if I enable mirroring again, the vertices were symmetrized. So that is a very nice way to fix symmetry issues. It is not perfect. Sometimes it fails. So I highly recommend that you take care to not lose the symmetry in the first place. But when you need to fix symmetry, then mesh snap to symmetry is the tool that you want. Some symmetry settings have a special option called Topology Mirror. Topology Mirror tries to look for symmetry not just in the location of the vertices, but also based on their topology, on the way the vertices are connected. So here I have this symmetrical character, and let's break the symmetry a little bit by moving some vertices around. And then maybe I'll go to sculpt mode and enable sculpt mode mirroring and smooth this area a little bit. And then in edit mode, I'll make sure that mirroring is on the x-axis and try to move some of these vertices. So some of the vertices are still fine, but where I tweak the vertices, we lost the symmetry, including this smoothed area here. However, if I enable topology mirror, Blender is now able to find the mirroring or the symmetry in these vertices. And as you can see, as soon as it finds it and moves both vertices together, they kind of snap to the same position. So that can be a way to fix bad symmetry. For example, if I select all of these vertices and just press G to move them slightly, you'll see that all the vertices on the other side snap to the symmetrical position of the vertices on the other side. And now even if I turn off the topology mirror, symmetry will work. But where this is more useful is, let's undo. And let's say that I have a character that has a symmetrical topology, but the character itself is asymmetrical. For example, let's go to sculpt mode, disable mirroring, and let's make this shoulder bigger, for example. So something like that. And topology mirror is also available in weight paint mode. And in theory, it should allow me to paint symmetrical weights for the left shoulder and for the right shoulder. And that kind of works, but sometimes it does break, so don't rely on this too heavily. Okay, let's switch topics, and now I want to talk about inverted normals, which is also very important if you want to keep your meshes high quality. In Blender and in 3D graphics in general, each polygon has a front side and a back side. On this plane that I have in my scene here, the front side is the one that I'm looking right now, and it is colored in blue, and then the back side is colored in red. This is defined by something called face normals, which define which side of the polygon is the front side. So in this case, the normal is pointing up like this. I believe in the early days of 3D, the backside of the polygon was never drawn in order to save computing power. But as computer became more powerful, they were able to easily draw both sides of the polygons. And now, since Blender is a modern 3D application, it always displays the backsides of polygons by default. This can be a good thing, especially when rendering scenes and stuff like that, because it allows us to work without having to worry about normals. And our meshes will always look fine from every angle. But normals still have many important implications, so it is important to understand them. So let's start from a new file and create a plane. Now again, by default, Blender renders both sides. But if I go to, first make sure that your viewport display is set to solid, and then if I go to the viewport shading options, I can turn on this back face culling option. Now if I look at the bottom face, you'll see that it is not rendered, it is transparent. If I press Alt-A to deselect this object, it will be completely invisible. And this is one way to check which side of your polygons is the front side and which is the back side. I think many people like this way, especially people who have been in computer graphics for a longer time. I tend to keep this option off personally. Another way to see the normals is to go to Edit mode and then look under the overlay options. And all the way at the bottom, you'll see these normals options. The first two icons display vertex normals, which are not as useful in our case. They are useful in other cases, which I'm not going to go into right now. And so the one that we want is the third icon, which is the face normal. And you may not see anything right away, but if you increase the size of the normal, you should see this blue line appear. Okay, if I create another object with more polygons like a sphere and go to edit mode, you'll see that each of the polygons of the sphere have a normal displayed. Okay, I'm going to turn this off now. And here is my favorite way to display the orientation of polygons. In object mode, or actually in any mode, you can go to overlays and you'll find the face orientation option. If you enable it, it will color code your polygons based on their orientation. Blue means front side and red means back side. On this sphere, if I delete some polygons, you'll see that on the inside it is colored red. And by the way, X-ray has to be disabled. When it's enabled, you cannot see this face orientation overlay. Now, how do you even end up with inverted normals? There are many ways, actually. Often objects imported from other applications may have the normals flipped. It may be a problem with the importer, exporter, and so on. Models imported from CAD applications are notorious for all sorts of problems, including inverted normals. And also there are many ways in which you can do it yourself. If I undo here, one such way is, for example, if I just press E to extrude a polygon, that won't create any problems. But if I select the whole sphere here and press E, this creates a weird copy of the sphere, and one of the copies is inverted. Let's undo. And another way is if I simply start working in the inverted direction, then anything I create from this object will have inverted normals. But let's not waste too much time with this because fixing inverted normals is very, very simple in most cases. Here I have a scene that I prepared in advance, and if we look at face orientation, what a mess, right? All of these meshes are part of the same object, by the way, and if I just go to edit mode, select all vertices and press Shift and N, you'll see that all of my meshes became blue, which means they were fixed instantly. This function is really good and reliable. Usually it even fixes open meshes correctly, which I'm not even sure how it does it. For example, if I have a copy of this sphere and delete a part of it, and I'm going to invert these normals on purpose. And now if I just select this whole mesh, with L by the way, and press Shift N, it will fix it correctly. I mean, it will fix it in a way that a human being would expect this to be fixed. So yeah, it's really nice. But there may be times when it fails to do what you want exactly. I'm going to load my initial scene again and enable face orientation. And now let's just pretend that Shift N doesn't fix the problems. What I can do is manually invert the normals. So I'm going to simply select a face which is inverted and go to Mesh, Normals, Flip. This whole Normals menu is also available with the shortcut Alt and N. And it has many options, but honestly, the ones that I use are Flip or Recalculate Outside, which is this Shift N that we used just a second ago. So yeah, I can also select the cube and press Alt N, Flip. That will also fix it manually. Incorrect normals can create many problems, so it's definitely worth learning how to fix them. Some of the most common ones that I see personally have to do with rigging and game engines. So let's see a quick example. Here I have a simple character and a simple armature inside it, and everything seems normal, so I want to parent this character to the armature with automatic weights. So I go Ctrl P, automatic weights, and then if I give it a try, it kind of works, but it looks really weird. I have gotten this particular question many times. So the solution is flip normals. If we check face orientation, we'll find out that our character has inverted normals. So I just have to select my character, go to edit mode, select everything, press Shift N, my character will turn blue, and then again I'll select my character, Shift select the armature, Ctrl P, automatic weights, and it seems that things are still not behaving quite well. So most likely the problems from when the character had flipped normals are persisting. So I need to reset things. I'm going to delete all groups and press Alt P and clear parent for the character and make sure that the armature modifier is removed as well. And now I'm going to repeat the same action, Ctrl P, automatic weights, and now everything is normal. Another common problem is when you're trying to use your object in a game engine. Again, in Blender, everything may seem fine unless you know that you have to check your normals, in which case you would know that everything is not fine. If you export this object to a game engine, like Unity for example, you'll see that all normals of your mesh are inverted, even though it seemed fine in Blender. If you fix your normals and then export again, it will be fine. Some game engines may offer solutions for that in the engine, like enabling double-sided materials and so on, but that will cost you performance. So it is highly recommended that you fix your normals in Blender and then export to a game engine. Okay, let's look at another category, which is overlapping and disconnected geometry and just general mesh messiness. A lot of the meshes that I inspect have these kind of problems. And so first, let's look at some of the ways in which you can create this kind of problems. If I go to edit mode and select a polygon and then press Shift D, for example, to duplicate this polygon, and then I decide that actually I don't want to duplicate this polygon, I could press Escape or right click to cancel this action, and it may seem like nothing happened, that I cancelled the whole duplication of the polygon, but actually if I press G, for example, right away, you'll see that, let's disable mirroring actually, but if I press G now, you'll see that this polygon was actually duplicated. So when I pressed Escape or right click, I cancelled the movement of the new polygon and not the duplication. In my opinion, that is a problem in Blender. Unfortunately, it is not the logical behavior that most people would expect from the software. So we need to learn these peculiarities of the software and keep them in mind. So here I have one overlapping geometry. Something very similar if I select another polygon and press E to extrude, and again I decide I don't want to extrude, and right click. Again, it may seem like nothing happened, but really the geometry is there, the new geometry is there. It's just collapsed at the location of the original polygon, and so it is not immediately visible, but it is there. Something else that you can do by accident is if you have a vertex selected and press V, you may want to press B for box select, but instead you press V, and that rips the vertex and creates a hole in the mesh. And again, if I cancel the movement, it will snap back to its original position, but it is still disconnected. Another one, if I have some polygon selected, if I press Y by accident, for example, at first it may seem like not much happened, but really I disconnected this geometry from the mesh. And now we have a bunch of polygons which are perfectly overlapping with existing geometry, but they are incorrect. They're not perfect geometry. So when you have overlapping geometry, one of the easiest way to fix it is to select all vertices and go to Mesh, Merge by Distance. And that will fix all of these problems. As you can see, this ripped vertex that we had is gone. The cancelled extrusion was fixed, and the cancelled duplication of polygons was also fixed over here. And this geometry that we disconnected was also connected again. So when the bad geometry is simply overlapping with existing good geometry, then doing merge by distance will very often solve the whole problem. But let's undo this until we have our problems back. Okay, sometimes, for example, I can select a polygon and again Shift D and duplicate it, and then I'm going to move it inside the mesh. So that is something else that you could do by accident. And now if I go to X-ray mode, I'll be able to see this polygon, but without X-ray, it will be invisible and hidden behind the geometry of my character. And now I can run merge by distance, and that will solve some of our problems here, but it will not correct this disconnected geometry that is inside my character. Oh, and by the way, another common way to create disconnected geometry is if I just select a single vertex and duplicate it. It's kind of visible here as a small dot in vertex mode, but if I switch to edge mode or a polygon mode, it is not visible. So that is another way in which you can create disconnected geometry and not notice it. So now merge by distance will not fix all of our problems here. So one thing that I can do is hover over the main mesh and press L, and that will select all connected vertices. And then I can press H to hide the mesh. And then I'll go to the other parts, like the hand and this other disconnected geometry that I had, hide it, and I'll be left with just bad geometry that I don't need. I'll select it by pressing A and then just delete all vertices. And now if I Alt-H and unhide the mesh, I won't have any floating geometry, but I still have some overlapping double vertices, so I can again merge by distance, and that will fix it, and that will give me a mesh without any particular mesh problems. By the way, one way to delete these floating vertices, if I create a couple of them, and then select everything and go to Mesh, Cleanup, Delete, Loose, that will delete these kind of loose vertices. And this whole menu of cleanup is a collection of useful tools when you try to clean up your geometry, so you may want to take a look at them. I'm not going to go over all of them because I find that this delete loose is kind of useful, and then other than that, merge by distance is the most useful tool that you can use. Another common problem with meshes is having holes in your mesh. Having holes can be acceptable. For example, if the head was a separate object like this and it was covered by some sort of cloth, it is perfectly fine to have this hole on the bottom of the head. But in some cases you can have holes that are undesirable, or you may simply prefer not to have any holes in your mesh for some technical reason. Then you could select all of your polygons and go to Mesh, and again the cleanup menu, and fill holes. And as you can see, that filled some of our holes in the geometry, these polygons that I deleted. But with the default options, it only fills polygons with 4 edges. So again, I'll select everything and fill holes, and then and then increase the number of sides. And then eventually it will also fill the hole in the arm, and also here in the head. I'm going to undo. Another tool to help you troubleshoot bad geometry is selecting non-manifold geometry, and that can be done from select all by trait, and then I have to switch to vertex mode. Select all by trait, non-manifold, and that gives me this menu at the bottom, which allows me to select the type of problems that the mesh could have. And let's create some problems first. Let's create this duplicate polygon and another one through extrusion, and then maybe rip a hole here. And now I'm going to select non-manifold again. And as you can see, it was quite good at detecting these problem areas. Let's create some floating vertices as well. And again, select non-manifold, and again it was able to select them. And you can click these options and see what each of them does. For example, boundaries is the holes in your mesh. Vertices are these disconnected vertices. And yes, this can also be useful. Interestingly, it didn't detect this problem here. But anyway. Now this type of messy geometry can create different types of problems. I don't think I can list them all, but one problem that I see a lot, and that is because of my series on Rigify, many people, when they try to parent a mesh to an armature, get bone heat weighting error. This error does not have one single solution, but very often it is because of messy geometry. The automatic weights in Blender are great, but they need relatively clean geometry to work correctly. And another area is when you try to export messy meshes to game engines. For one thing, the messy geometry, the overlapping vertices and polygons and so on, create needless data, and that will make your game assets heavier and less performant. But even worse than that, often the game engine may not even accept such meshes. It can give you some sort of error, and you may not be able to import the mesh. Now you should know some of the main ways and main tools to detect and fix bad geometry, and I hope this helps you create better quality meshes. Another problem that I see surprisingly often is simply meshes that are way too dense. Here's the wireframe of this object. It is fairly low poly. This is not a standard that you have to strive for. Modern games and modern animation can support much more polygons than this, but from time to time I see something like this. If I go to sculpt mode and enable Dyntopo and set the detail size to something very low and then start sculpting, you'll see that the polygons are getting really dense. And that is fine, for example, when you're concept sculpting, but when this mesh has to be used in a game engine or for animation or for something like that, then something needs to be done. There is a decimate modifier which can help with that if you need an automatic solution. A ratio of 0.1 or even 0.05 or so will improve this quite a bit. Or this mesh has to be manually retopologized, which is a whole other topic. Keep your poly count reasonable, decrease it as much as possible without losing quality. And there is no hard rule on this, but if I remove the decimate modifier, if your polygons are so small that you cannot even see them, then maybe you're overdoing it. So let's try to put all of this together. All of the tips that I shared throughout this video, let's see how they work in practice. Let's say that I want to create a symmetrical character. I'm going to start with a new scene and make sure that the 3D cursor is at the center of the world. If it is not, then press Shift S and choose Cursor to World Origin. That way, any object I create from now on will appear right in the center of the world, and that will help me avoid any type of location issues. Now I can add an object to start modeling from. A cube is a common one for this purpose. Location is set to 0, 0, 0 because I had the 3D cursor at the center of the world, and rotation and scale are always at the default state when you create a new object. So from now on, I'll just take care to keep all of these things that way. And I do that by never moving, scaling, or rotating this object in object mode. All changes to the object will be done in edit mode. In edit mode, I can go to front view, move the cube to the side, and then I'm going to delete this side polygon. Now I'm going to add a new mirror modifier, enable clipping right away, select all polygons, then I'll move the cube on the x-axis until the two sides connect, and that will give me my center line. And thanks to clipping, I'll never be able to destroy this center line. Right away, I'm going to check my normals. My object is blue, so everything seems fine, so I'm good to go. I can start modeling, and if I'm careful, I'm going to end up with a character that has proper normals. Okay, I swear that that's not the level of my actual modeling skills, but the point here is that I have an object that is symmetrical, the mirror modifier is applied correctly, there is no polygon in the middle, the center line is correct, normals are okay, and if I hide this main chunk of the mesh, I won't find any floating geometry. If I try to merge by distance, Blender would tell me that 0 vertices were merged because there are no overlapping geometry and so on. I really hope this was useful. These are some of the most confusing problems in 3D modeling, in my opinion. And I really hope that thanks to this video, you'll be able to integrate these techniques into your day-to-day modeling, and it will save you a lot of time. And I hope you experience less errors and less confusion. Try to understand these issues and try to make avoiding them a habit. When it becomes a habit, you won't even have to think about it. If you have a problem that I didn't mention, feel free to get in touch. I'm always interested in seeing weird bugs and glitches and so on. And as I said in the beginning, here are some resources if you want more of a step-by-step modeling lessons. One of the best instructors for beginners, in my opinion, is Abbitt. Just head to his channel and choose from one of the many step-by-step tutorials that he has for you. And another one I recommend is Deco. If you want to learn about topology, which is kind of related to this video, Deco has the most practical videos on the topic that I know of. Links will be in the description. As always, huge thanks to my Patreon supporters. If you like what I do here, if you like thorough video tutorials, please consider joining us on Patreon. I have now also enabled YouTube memberships. That is another great way to support the channel. Look for the join button below the video. Thanks for watching and talk to you soon.